Cool. So we've got a different situation here where we have a polynomial with an unknown in it, and the only hint is that we have a purely imaginary zero. So what that means is that if we were to write the root in, say we had alpha, and we had it as AIB, what this means is because it's purely imaginary, it simply means that there's no A, it's just IB. And because of that, even though we're being quite vague in the information we're given, we actually have enough information to solve this particular problem. So the way in which we do this is we simply declare what the imaginary root is going to be. In this instance, would say the zero has to be a given that it's purely imaginary, what this means is that our alpha has to be IB, and hence our beta has to be the conjugate of alpha, which has to be negative IB. Does that make sense? So we don't know anything except it's purely imaginary. So because of that, there's no real component. Now, using this, we're actually able to build a polynomial that's equivalent to this guy, but in factorized form. If we know that the roots are going to be, the zeros are going to be alpha, beta, which is IB and negative IB, then using our sum and product, we discover that we're going to get negative IB, take IB, or plus negative IB, which is 0, and our product is going to be alpha beta, which is simply IB negative IB multiplied together, which gives us negative I squared B squared, which just becomes B squared. Making sense? Okay, using this, we're able to build a new polynomial. In this case, it's going to be P of X will be equal to, this guy is going to come together to give us X squared. There's no sum, there's a 0, so it's just plus B squared. And then it's going to be linear. So X plus, we haven't used C yet, so we'll just use C. And then let's just say that we've got D at the front. That'll work. Do we agree so far? Alright, next step, when we've got a polynomial to this stage, what do we do to it, Patrick? We've got a factorized form with unknowns. What do we need to do to start figuring out the unknowns? Yeah, we have to expand it. So this will look like it's in this form, and then we can start playing matchy-matchy across the two forms, the two expressions. So because of that, let's bring D into this guy. So it's going to be X squared plus B squared dx plus dc. And of course, D in this instance is a value that's non-zero, and C is just some real value. It's got to be real. Alright, expanding this out using synthetic. Let's go 1, 0, B squared. Might be tight for space here. In fact, I am tight for space. Oops. So we get p of x equals dx cubed plus dcx squared plus b squared dx plus b squared cd. Do we agree?
Yeah.
Alright, cool. And then it's just a case of matchy across. So looking at this, you can see that d clearly has to equal a because d's there, a's there. From there we could go, I like to go the constants first, so 10 and 15. 10 has to be this guy, b squared d, but d equals a, so 10 equals b squared a. From there we can say 15 equals b squared cd, but d equals a. So 15 is b squared c a, or a b squared a b squared c. That looks alright for now. And then I suppose you can solve for c in this instance because you can get rid of the a squared or ab squared. So that would be 15, that's going to be ab squared equals 15 over c. So this is going to be 15 over c, which is 10, which means that c is going to be, what's that? 1 over 10 c has to be 3 over 2. Does that make sense?
Yeah.
Okay, and then we need to use this to form the final equation, a plus 1. So just go over here, dc. We know that d is a, so it's ac, a plus 1. So in this instance, we know that c is 3 over 2. Not sure if I'm happy with that choice, but anyway. So if we take a from both sides, we're going to get a half a. A equals 2. So far so good. And then we can just use this guy over here. So we'll go, well, it's really messy, but anyway. 2b squared b equals plus or minus root 5. So far so good. Alright, now assuming that we did all of this somewhere on our paper to find the values of a, b and c, so a equals 2, b we discovered was plus or minus root 5, and c we discovered was, what was it, 3 on 2. Let's just get rid of this. And d of course was just 2. then what we deduce is this guy over here, p of x, was equal to x squared plus b squared, which was dx plus dc. Okay. B squared is just 5. D is 2 plus, and then we're going to have dc, so 2 times, let's just pull out the 2 here. Still cool? And then we need to factorize this using dots. Difference of 2 squares. Now, see how to plus it? We can still treat this like it's a difference of 2 squares situation, but we just change the form. Rather than being a real component, it's going to have an imaginary component. Yeah? So you just throw in the I, because if you expand it out, the I will swing this from being a negative to a positive. So, yeah. Cool? So the point is, when we're dealing with purely imaginary, they can get away in the question without giving you as much information because the equations that you form are have less unknowns. So it's actually easier if they give it to you this form. Cool?
Yeah.
Wonderful.